Today I will be coding a simple Python program to check whether a number is odd or it's an even number. Now there is only two possibilities when it's come to odd and even, and the logic behind is that if a number is even, then it should be divisible by 2. That is, when you divide any number by 2, the remainder should be 0. That is when a number is even. And if a number is not even, then it's an odd number. Now let us take an input from the user to check whether it is an even number or an odd number. So we take a variable num equals to int input. See, in Python, by default the input is in string, so we have to convert it into integers. Okay, now let us check for the number. If the number mod 2 equals to 0, that is, if the remainder, when you divide the number, the remainder if you get it is 0, then print f string. We are using f string so that we can use the number with the, that is, the integer with the within a string. So print the number is an even number. Now else, obviously that we will write another print statement that the number is an odd number. And yeah, it's an odd number. Now let me check the output for it. Okay, let us enter 35. It's an odd number. Now let us enter an even number, 88. Today we'll be coding a simple program to check whether a number is a prime number or it's not a prime number. So it's a prime number checker. So what is a prime number? A prime number can be defined as, that is, a prime number is a number which is not divisible by any positive number other than the number, other than 1 and the number itself. So how do we code? Now let us define a function to check the prime number. So define prime checker, and we'll take num, that is the number for which we will be checking whether it's a prime number or it's not. Okay, another thing to note is 1 is not a prime number. So if the number is greater than 1, then only we'll be checking for it. So for I in the range from 2 till that number. Now the upper limit is n only, because here the number is not include, because in this case we need to check it before that number, because that number is only divisible now. That is the reason. Okay, so if any other number is divisible, that is from in this range. Okay, if any number is divisible, that is if num mod I equals to 0, then it's not a prime number. Break out of the loop even if it's divisible. So we do not, if one number is divisible, we do not need to check if another number gets divisible. Once it's divisible, means it's not a prime number. Now come out of the loop and write else it is a prime number. Another thing to note, that if it was 1, in that case it is, we will be printing as 1 is not a prime number. If the suppose if the user has inputted 1, for that case we will be printing 1 is not a prime number. Okay, now we will be taking, so this was the function. Now we'll be taking an input from the user and we'll be converting it to integer. So int input, enter the number you want to check. Okay, and we will be calling the function on the input. Okay, let us check an output, and the number 15 is not a prime. Okay, good. Then 17, yes, this is a prime number. So it's a working code. Thank you for watching. Okay, today I will be coding the program to find the factorial of a number. What is factorial of a number? The factorial of a number can be defined as the product of all the positive integers up till that number. So for example, if we want to find the factorial of 4, then it will be 1 into 2 into 3 into 4. That is equal to 24. So factorial of 4 is 24. Okay, there in this program we will be taking two cases apart from the main code. That is when the input is 0 and when the input is less than 0. So first let us take an input from the user. Num equals to int input, enter a number. Okay, and we'll take a variable fact equals to 1. Okay, the first thing we'll be coding that the num should be, if the num is 0, then it is not accepted because the factorial of a negative number does not exist. So if the number is less than 0, we will print the statement factorial of negative number does not exist. Okay, the second case will be if the num equals to 0. See, for 0 the factorial is always 1, so we have to write these cases separately. So for if num equals to 0, print factorial of of 0 is 1. Okay, now the next part is the else. Here we will be actually finding the factorial of a number which is given by the user. Okay, so for I in the range from 1, the range will be from 1 up till that number plus 1, because in the for loop the upper range is not taken in case of Python. So we will be coding it, we will be taking the range from 1 to num plus 1. Then fact will be fact into equals to I, which can also be written as like fact is equal to fact into I. Okay, here it will be calculating the product. Then we'll exit the for loop and we'll write finally the factorial. We will be using f strings. So factorial of the number is okay, in fact. Now let us check the output. Output for it, yeah. Enter 5. Factorial 5 is 120. Another number, that is 4. 4 is 24. Okay. Another 7. 7 is 5040. So it's a working code. Thank you for watching. Okay, today we'll be coding for Armstrong number within a given range. That is, the range will be mentioned by the user. For example, if we want to find the range from 1 to 200, within this range, we want to find what are the Armstrong numbers, this program will be doing that. So what's an Armstrong number? Armstrong number can be defined as a sum of its own digits raised to the power of the number of digits. That's an Armstrong number. For example, take 153, which is an Armstrong number. Here the number of digits is 3, that is 1, 5 and 3. And so the power we have to raise it is still 3. So 1 to the power 3 plus 5 to the power 3 plus 3 to the power 3, which is equals to 1 plus 125 plus 9. That is 153. So it's an Armstrong number. Now let us take the input range from the user. We'll take a minimum, that is a lower range, and a maximum, that is the upper range. So min equals to in input, enter the lower range. Now we are taking int input because in Python by default the Python takes a string as an input, so we have to convert it to integer. Then max is int input, enter the upper range. So we will be getting the range from the user. Okay, then we need to define the write the code for the order. No, we need to loop it actually. So we need to find write a for loop for it for num in the range that is min to max plus 1. Now we will not take max because in Python the upper range is not taken, that number is not taken, but we need to include that range. Suppose it's 153 only, so 153 is an Armstrong number, so we have to take it. So for the range we will write min and max plus 1. Okay, so now next is we need to find the order. That is, we need to convert that number to string and then find the length of the string to get the order. So it's 153, then length of string, then the order will be 3 because it will be taken as string. So we can find the length. Okay, then take a temporary variable sum equals to 0 and another, no, sum is equals to 0 is to calculate the sum of the digits. Okay, then temporary variable equals to num, then while temp is greater than 0. Now we are not using num, but we are using temp because it will be going till 0. So we're writing a for loop. Now digit equals to temp mod 10. For example, if it's 153 mod 10, then we'll obtain the digit 3. Then it will be then the summation will be the digit to the raised to the power order. Then in this case it will be 3 to the power order here is 3, so 3 to the power 3 is 9, and we'll be keeping that sum in the sum variable. Okay, then we will divide the temporary variable by 10. So the 153 by 10 is 15. Then again the digit will be then 15 mod 10, which will get the second digit 5. This is likewise we will be getting the digits. Okay, now if the number equals to sum only, then print the sum. Then only it's an Armstrong number, right? Let's check the output for up from 1 to 200. It's 1 2 3 4 5 6 7 8 9 153. Yes, so this is working good. Okay, today we'll be coding a program to check whether it's a leap year or not. Okay, so we'll take the year input as integer, because in Python the default input is string, so we need to convert it to int, so integer. So int input, enter the year. Now see, notice if the year is a century year. Okay, so like if the year it is divided by 100, gets that is, if the year gets divisible by 100, then it is called a century year. Okay, that is the year ends with 00. For example, you can say the year 2000. Okay, it's a century year because it ends with 2 zeros at the end. Okay, so for a century year, if it is like, if it's a century year, then if it is divisible by 400, so if it is divisible by 400, then only it's a leap year. Okay, so here if it is divisible, it's not divided, it's actually divisible by like year divided by 400. If it is it's completely divisible, then it's a leap year. Okay, now so if the year mod 100, okay, so that is if it is divided by 100, and if the year mod 400, so it's a century year, and also if it is divisible by 400, then it is a leap year. So we write a f string, the year is a leap year. Okay, now what if it is not a century year? Then for a non-century year, that is, if the year is not divisible by 100, in that case that is a non-century year. So for a non-century year, the year, if it has to be divisible by 4, then only it is a leap year. Okay, so you will write an elif statement, elif year mod 100 not equals to 0. In this case, not equals to 0 because it is a non-century year. Okay, and the year mod 4 equals to 0. Yes, now in this case this is also a leap year. For example, you can say like 2004 is a leap year. Okay, and it's a non-century year, so it's also a leap year. Else then obviously if it does not satisfy these two conditions, it is not a leap year. This year is not a leap year. Okay, let me check the output. 2000. Okay, 2000 is leap year. Good. Then 1988. Oh, it's a leap year. Say 1947. Not a leap year. Then 2024. Oh, this year is a leap year. Okay. Thanks for watching.